Hey y'all. Okay. We are going to do another problem where it has us list all of the possible rational zeros. And then from that, we're going to be able to use synthetic division and we're going to be able to find the other zeros. Okay. So say what they give us is, am I zoomed in? Just have to scroll around here. I get f of x equals 6x cubed, a positive 25x squared, a negative 24x, a plus 5 equals 0. Y'all, whenever you see a function set equal to 0, I've been telling you, like, that means that we're going to find the values that are 0. In the previous sections, it was what makes this function 0. In the synthetic division, like 3.3, 3.4 section, it's actually finding what we call our zeros. Set it equal to 0, you find your zeros. Okay, so the first thing you need to do whenever you have a problem like this is to actually list all of our possibilities, the values that may or may not, whenever we synthetic divide, give us a remainder of 0. And that's because it doesn't tell us to divide this by anything specific. So to do that, we take the positive and negative values of our P over Q. Our P is our constant term, and our Q is our leading coefficient. And we actually are going to take the factors of those. So I would get 1 and 5 because 5 is prime. And I would get 1, 2, 3, 6 for my 6. And then we're actually going to list them. And so you could do plus or minus. I would have a 1 over 1. I would have a 1 over 2. Why did I do that? I would have a 1 over 3. I would have a 1 over 6. I would have a 5 over 1. I would have a 5 over 2. I would have a 5 over 3. And I would have a 5 over 6. Now, to actually solve this one and list them, I do need to take into consideration that there's a positive and a negative value of each of them. So if you look at 1 over 1, that's just 1, right? And I have a positive and a negative 1. Then 1 over 2, that's 1 over 2. I have a positive and I have a negative 1. Same with my 1 over 3. Same with my 1 over 6. These aren't actually reducing, right? If they do reduce, of course, that's the answer that you put there is the reduced answer. My 5 over 1, that's just 5. I have a positive and a negative 5. And then I'm going to have a positive and a negative 5 halves. I'm going to have a positive and a negative 5 thirds. And then lastly, I'm going to have a positive and a negative 5/6. I had to write that all weird. It won't write on the side of my screen. Okay, so there's my long list of possible rational zeros. I'm pretty sure I said it in the previous. There's an actual rule that we could use. It's called Descartes' rule of signs. We're going to learn that later. For now, this is the process we have that will act as a shortcut. Y'all, all I did was write down the function. I didn't like the polynomial. I didn't actually solve this. So I don't want to start with 1. I feel like if I start with 1, a negative 1, oh, that didn't work. Oh, that didn't work. I'm going to start with the fraction. I'm going to start with 1/2. So what I mean by that is we are actually going to bring down our coefficients and we are going to do synthetic division. Once we find something that is a 0, from that point, we can actually very easily find the other zeros. Bring down, I get 6. 6 times 1/2 would give me 3. And then I combine 28 and 25 and 3 is 28. Multiply by 1/2, I would get 14. Combine, I get -10. It just worked out, y'all. And then if you do -10 divided by 2, you get 5. Signs are different, so it's negative. Y'all right here gave me a 0. Perfect. This tells me that 1/2 is a 0. That is the exact same thing as saying that 2x minus 1 is factor of this polynomial. Y'all, I just looked at my 1/2 and I knew it came, like if it was written in this form, I just needed to look to see how was that form written. I know I would move this this 1 over first and get -1, and then I would have had to have divided by 2, so that means it was multiplying by 2. Okay, so I've got those facts. Now what I'm going to do is actually the quotient that I got, let me go ahead and throw this into parentheses. This quotient that I got, I'm going to write it down. It started x cubed, now it's x squared. So that means that would be my x, and this would be my constant. And my original problem was set equal to 0, which is why I know I'm solving for all 5 zeros, and this is how I would find them. Technically, you would have both of these factors set equal to 0, but if you notice that second factor is a trinomial, you can do the quadratic formula. I think I'm just going to do the AC method. And so I would do 6 times 10 is 60. Signs are different, so it's negative. Y'all, I want space below me, so I'm going to do this. I get 1 and 60, 2 and 30. I don't even need to go on because those are my two factors. If I make my 2 negative, they'll combine to give me a positive 28. And if I do the multiplication, I get to -60. So that's actually what I'm going to replace. And what I get is 2x -1. Let me see, that's a 6x. You know what? Instead of doing it this way, my answer is going to go here, y'all. I literally wrote my factors sideways so I could work over here. So let's work over here. I get 6x squared. That's a -2x. That's a positive 30x. That's a -10 split 2x 3x. 6 divided by 2 is 3x. And then this would give me a -1. Bring down the plus sign. They have a 10 in common. That gives me a 3x. That gives me a -1. Awesome. That means I have 3x minus 1 and 2x plus 10. Now what you do is if I set all of these equal to 0, I get that my x equals a 1/2. If I set this equal to 0, I would get that x equals 1/3. And if I set this equal to 0, I would actually get that my x equals -5. So I would have -2. I would have -10, right? Move that 10. Then I would divide by 2. Signs are different. So it's a -5. So my x values are 1/2, 1/3, -5. And that would be the final answer for that problem. Okay, y'all, if y'all have any questions, make sure y'all ask, okay? Thanks. Bye.